When it comes to nuclear bombs, the reality is simple. There's no suitable location to detonate one. These weapons represent catastrophic outcomes in virtually every circumstance. However, certain locations make nuclear detonation an exceptionally disastrous choice. Space ranks among those particularly terrible locations, which might seem counterintuitive. After all, space exists at great distances from Earth and consists mostly of emptiness, doesn't it? So what could possibly go wrong? The United States military possesses a brief yet consequential record of nuclear detonations in space. Theoretically, detonating a nuclear device high above Earth offered potential benefits from both protective and aggressive perspectives. As a protective measure, space-based nuclear detonations could potentially safeguard the United States against Soviet intercontinental ballistic missile strikes. The concept relied on the fact that nuclear explosions generate electromagnetic pulses and zones filled with highly charged electrons. These phenomena prove lethal to electronic systems, including the guidance mechanisms within long-range nuclear missiles. Intercontinental ballistic missiles don't traverse the ocean like conventional aircraft. They operate like rockets, launching upward through the atmosphere and crossing into outer space before descending to reach their intended targets. Should these missiles return through a barrier of electromagnetic disruption, the interference could compromise or completely disable their electronic systems. An offensive application for space-based nuclear detonations also existed. During the late 1950s, scientists verified that Earth possesses a robust magnetic field. This field originates from the planetary core, where a solid iron sphere forms the inner core, surrounded by a layer of freely moving liquid metal in the outer core. The motion of this outer core functions as a massive electrical generator, powering Earth's magnetic field, which extends outward from the core and reaches deep into space. This phenomenon manifests as circular magnetic field lines flowing from the southern hemisphere toward the northern hemisphere. These lines form concentric layers of magnetic field that envelop Earth from its surface to hundreds of miles into deep space, resembling a gigantic magnetic onion with a planet at its center. The outer layers of this magnetic structure can capture highly charged radioactive particles from the sun and contain them in deep space, preventing their arrival at the surface. This mechanism represents one of the fundamental reasons life exists on Earth, so we owe our thanks to magnetism. We can observe this effect directly when some charged particles travel down along the magnetic field lines into the sky above the North Pole, creating what we know as the Northern Lights. Detonating a thermonuclear device essentially creates a miniature sun instantaneously. If such a detonation occurred within Earth's magnetic field, it should produce results similar to what happens with the actual sun. The highly charged radioactive particles would become trapped and drawn along the magnetic field lines. While the outer layers would direct their captured particles over the North Pole, the lower-lying inner layers would release their electromagnetic chaos at lower latitudes, such as over the Soviet Union. That explanation was lengthy, but understanding it proves essential if we're to comprehend why anyone would consider nuclear detonations in space. The focus isn't primarily on the explosion itself, but rather on the electromagnetic consequences it produces and how those interact with Earth's magnetism. Theoretically, a thermonuclear explosion strategically positioned above the Indian Ocean would release an electromagnetic pulse that would become entangled in a magnetic loop and deposited over the Soviet missile defense infrastructure, rendering their electronics inoperative and eliminating their capacity to detect and defend against a long-range nuclear assault. Of course, the only method to validate these theories involved detonating a high-altitude nuclear device and observing the results. Remember, this occurred in the late 1950s, when conducting live above-ground tests of immensely powerful nuclear weapons was standard practice at the time. All right, I have something for those interested in military history. This is War Thunder, the most comprehensive vehicle combat game ever created, and it's currently available at no cost on both PC and consoles. Take control of over 2,500 tanks, planes, helicopters, and ships from 10 major nations, ranging from biplanes and armored vehicles of the 1920s to contemporary fighter jets and main battle tanks. War Thunder features one of the most advanced vehicle damage systems in gaming. Every vehicle receives intricate modeling down to individual components such as engines, fuel tanks, weapons, and crew members, all vulnerable to damage or disabling from enemy fire. Join a global community exceeding 70 million players in epic player-versus-player battles today, and immerse yourself in the breathtaking experience that is War Thunder. With an unmatched quantity of high-quality content to explore, there's simply no game more suitable for military history enthusiasts. Play War Thunder at no cost on PC, PlayStation, or Xbox now by using my link in the pinned comment or video description. New players and returning players who haven't participated in 6 months will also receive a substantial bonus package across all platforms. This includes multiple premium vehicles, the exclusive vehicle decorator Eagle of Valor, 100,000 Silver Lions, and 7 days of premium account access. It's available for a limited period only. So act quickly. During the months spanning April through August 1958, the U.S. military executed a sequence of 35 nuclear weapons tests under Operation Hardtack. These occurred at locations the government designates as the Pacific Proving Grounds, which comprises a collection of tiny islands in the central Pacific Ocean, so small that most of the world remains unaware of their existence. You must zoom in 10 times on Google Maps simply to view them clearly. Among these experimental nuclear explosions, 3 would be high-altitude tests. The first, codenamed Yucca, would attach a 1.7 kiloton nuclear device to a hot air balloon and release it into the upper atmosphere. That approach sounds questionable, and it certainly was. However, in fairness to the Army, they did invest 2 years practicing for this operation and deployed 76 test balloons before ultimately allowing one to drift away, carrying a nuclear bomb. Yucca was launched from a U.S. aircraft carrier off the coast of Bikini Atoll on April 28th. The balloon was released at 11:25 in the morning. It reached the target altitude of 85,000 feet by 12:50, and at 2:40 in the afternoon, the relatively small nuclear device was detonated. The significance of this test centered on measuring the electromagnetic pulse strength created by the explosion. Scientists had theorized that a high-altitude electromagnetic pulse would carry greater intensity than a ground-based explosion, but they didn't know the magnitude. Measurements from Yucca confirmed that a high-altitude electromagnetic pulse can exceed the intensity of the same explosion at low altitude by more than 1,000 times. While that information might seem alarming, it was precisely the result the military sought, so they continued forward. The subsequent test, codenamed Teak, would substitute the balloon with a Redstone missile and increase the explosive yield to 3.8 megatons. The location was relocated to the government's most isolated outpost, Johnston Atoll. It's situated west of Hawaii and approximately as close to the absolute middle of nowhere as geographically possible. Teak was launched at 11:47 in the evening on July 31st. The warhead detonated at an altitude of 76 kilometers or 43 miles. That's not technically space, but it's remarkably high. Unfortunately, the missile's guidance system wasn't programmed correctly, so instead of heading downrange over the ocean, Teak exploded directly above Johnston Island. This created a miniature sun within Earth's atmosphere that remained visible from 800 miles away at Hawaii and persisted in the sky for almost half an hour. The thermal radiation possessed sufficient strength to give the servicemen on Johnston sunburns. It also disrupted high-frequency communications across the Pacific for 8 hours following the detonation. Once again, a fairly frightening effect from a relatively small bomb that truly began to demonstrate the power of space-based nuclear detonations. So just for good measure, the U.S. attempted this once more, codename Orange, on August 11th. This was another 3.8 megaton bomb on a Redstone missile. The difference was that Orange exploded at an altitude of 43 kilometers or 27 miles. The result was considerably less spectacular than Teak. The explosion remained visible in the sky for only about 5 minutes and did not produce the same communications breakdown. So now we understand that higher altitudes do have a significant impact on the consequences from a nuclear explosion. What comes next? It would require a few more years of planning before the U.S. Army was genuinely prepared to conduct nuclear detonations in space. But the time would finally arrive with Operation Fishbowl in 1962. This was the same year as the Cuban Missile Crisis that nearly ended human civilization as we understand it. Probably just a coincidence, though. Anyway, this was about more than simply a Cold War arms race competition. Fishbowl was a collaborative effort between the military, the Atomic Energy Commission, and the Defense Atomic Support Agency. This was about continued investigation of the potential for high-altitude electromagnetic pulses, the interaction between radiation from the blast and Earth's magnetic field lines, plus the effect of all this on radio communication. The fishbowl tests were monitored by a substantial number of surface and aircraft base stations in the wide area surrounding the planned detonations, and also in the southern hemisphere region of the Samoan Islands, which was designated in these tests as the Southern Conjugate. The concept was that fallout from an explosion over Johnston Island in the northern hemisphere would become entangled in a magnetic field line connecting to Samoa in the southern hemisphere, which would create an aurora linking the two island regions. Examining the actual results of Operation Fishbowl, they were quite inconsistent in accomplishing their objectives. It's actually somewhat shocking just how frequently they botched some of these nuclear tests. We're truly all fortunate to be alive. Anyway, the first planned test was codenamed Bluegill. This was June 2, 1962, and the warhead was launched from Johnston Island on a Thor rocket just after midnight. The missile was promptly lost on radar tracking, so they knew they had just launched a nuclear weapon into space, but they didn't know its exact location. Fortunately, the flight termination system remained connected, and the missile was destroyed. That doesn't mean the bomb detonated. It was still in safe mode, and the wreckage simply fell into the ocean. Attempt number 2 was codenamed Starfish. This was a couple of weeks later on June 19th. Another Thor missile launched from Johnston. This one flew for 59 seconds before the rocket engine failed and the missile broke apart at around 30,000 feet, raining down plutonium-contaminated debris onto the island and surrounding water. Undeterred, the military pressed forward with Starfish Prime on July 9th. This time, the Thor missile would carry its 1.4 megaton thermonuclear payload all the way to an altitude of 250 miles or 400 kilometers above Earth's surface, where it would successfully detonate a nuclear device in space. This would be recorded as the largest nuclear weapons test ever conducted in space. The thing about a nuclear explosion in space is that it doesn't resemble anything like what we generally envision a nuclear explosion to look like. There's no mushroom cloud because there's no dirt to be pulled up into the air. There's no fire because there's no oxygen to combust, but there is still an intensely bright light. It expands outward from the detonation in a round spherical shape until it begins to gradually feather off at the edges into these short, curly tendrils. It resembles some type of sea creature or a cactus. It's somewhat beautiful until you recall the terrible consequences of what you're observing. The electromagnetic pulse generated by Starfish Prime was significantly more powerful than the scientists involved had been anticipating, so much so that it overwhelmed most of their instruments and drove them beyond the scale, making it nearly impossible to obtain an accurate measurement. All we know is that it exceeded the maximum number the tool was capable of measuring. The electromagnetic pulse caused electrical damage on the Hawaiian Islands, 900 miles or 1,400 kilometers away from Johnston. It knocked out streetlights, triggered burglar alarms, and damaged telephone communications. After the Starfish Prime detonation, bright auroras were observed in the detonation area as well as in the southern conjugate region at the Samoan Islands. A very large area of the Pacific was illuminated by the auroral phenomena from far south of the South Magnetic Conjugate area through the burst area to far north of the North Conjugate area. This confirmed the theory that charged particles from the nuclear blast would be transported over great distances by Earth's magnetic field lines. It was also reported that resonant light from the explosion hung in the night sky over Johnston Island for several days. High-energy electrons from the explosion became trapped in Earth's magnetic field, creating an inner radiation belt around the Earth. The intensity of electrons in low Earth orbit actually increased by several orders of magnitude as a result. 3 orbiting satellites were disabled within a matter of days. Remember, in 1962, there weren't very many satellites in orbit at the time. At least 6 more satellites failed over the following months as radiation damage eroded their solar power and electrical systems. In 1968, it was reported that electrons from Starfish Prime had remained in the atmosphere for up to 5 years. The following year, 1963, the United States and Soviet Union signed an agreement that would prohibit all above-ground nuclear testing, although the French and Chinese would continue conducting their own tests for decades to come. But that fortunately put an end to the short history of nuclear detonations in space. There were other tests conducted, but they weren't as large as Starfish Prime. What's genuinely frightening is that Starfish wasn't even a particularly large test. There were plenty of bombs manufactured that were 10, 20, or even 30 times more powerful. Many of them, unfortunately, still exist today. It kind of goes without saying that if anything similar were to be detonated today, we would face a pretty significant catastrophe. Many of the important satellites in orbit are radiation shielded, GPS satellites, for example. But most of the 10,000 objects floating around up there are vulnerable. They wouldn't just fall out of space. Even worse, they'd all become a bunch of uncontrollable projectiles hurtling around up there until they eventually start colliding with each other and creating a field of orbital debris that grows exponentially and smashes more things until everything in orbit is destroyed. And then, of course, there's the electromagnetic pulse. You don't even need to destroy your enemy if you can just detonate a giant nuclear device in space directly above their country and send them back to the 1800s. Anyway, long story short, we know what happens when you detonate nuclear weapons in space. It's deeply fascinating and visually stunning, but equal parts terrifying and potentially apocalyptic. So let's hope we never witness that again. Shout out to War Thunder again for sponsoring today's video. Make sure to check out War Thunder now for free on PC, PlayStation, or Xbox, and use my link in the pinned comment or video description to register. Those of you who are new or haven't played for 6 months will also receive a massive bonus package across all platforms, including multiple premium vehicles, in-game currency, and more.